Today we are solving literal equations. What that means is that we will have a formula and you're going to see more than one variable in the equation. And sometimes that gives people anxiety. There's no numbers. Oh no, there's only letters. But really it makes it easier because you can't make any calculation errors. You only need to be able to recognize what operations there are and then perform the inverse operations. So you make sure you start outside of grouping symbols if there are any, and then you want to do adding or subtracting. Whichever one is with the variable, you'll do the inverse. And then multiplying or dividing, which are inverse operations. Whichever one is with the variable you're trying to isolate, you do the inverse. And then if there's a square power, the inverse operation is a square root. And vice versa, if there's a square root, you'll use square power these are operations that cancel each other out. So when it says solve for b, we're trying to isolate b. So what's with b is this addition sign, and we are adding mx. So the inverse operation of adding is subtracting. So I'm going to subtract mx from both sides. So these cancel out here. And then y minus mx, they're not like terms that can be combined. So we just write it as y minus mx equals b. And as you can see, that now got b by itself, and that's what it means by solve for. We're just using inverse operations to isolate the variable. Number 2 says solve for h. H is being multiplied by b. When there's nothing between these two variables, that indicates multiplication. The inverse operation of multiplication is division, so I'm going to divide both sides by b. On this side, the times b and divide by b cancel out, so we have h by itself. That's what we're trying to get by itself. And then on the other side, we have a divided by b. Number 3, they're asking us to solve for w. So we look at what's with w. It's multiplied by 2, and we're adding 2l. So first, we want to get rid of this addition. So I'm going to subtract 2l from both sides. So on the left side, we've got p minus 2l. On the right-hand side, we still have 2w. So there's nothing between the number and the variable. That means multiplication. The inverse operation of multiplication is division. So divide both sides by 2. And it cancels out. The times 2 and divide by 2 cancel out. So that gets w by itself. And that was our goal. Number 4, asking us to solve for c. So we want to first get rid of this plus 32 that's with the c. So I'm going to subtract 32. So on the left, we have f minus 32. Over here, 9/5 times c. So c is being multiplied by 9/5. The inverse operation is to multiply by the reciprocal. So we've got to make sure we multiply all of both sides by 5/9. So we do have to put parentheses around the f minus 32. On the right-hand side, 9/5 times 5/9, those cancel each other out. So we get c by itself. And then this is our final answer. For number 5, we're trying to solve for r. R is being squared and multiplied by pi. First, we're going to undo the multiplication by dividing both sides by pi. So the times pi and divide by pi cancel each other out. And then to get rid of the square power, we take the square root of both sides. So our final answer is r equals square root of a divided by pi. In number 6, we're being asked to solve for b. So we're adding a squared to b squared. So first, let's get rid of the addition. So I'm going to subtract a squared from both sides. So that leaves us with b squared equals c squared minus a squared. So b is not quite by itself yet. It's being squared. The inverse operation of square power is square root. So we take the square root of both sides. So on this side, that square power and square root cancel each other out. So we get b equals the square root of c squared minus a squared. Thank you for watching.